Hello. So today we're doing our learning check on 8.04 Gibbs. Has a little bit of review in there as well. So as always, after I do the introduction, hit pause and get as far as you can, and then rewatch the video if you need to. So in this one, you're doing a combustion of liquid octane, which has the formula C8H18. You're going to balance the reaction for step one. Tell me if it's endothermic or exothermic and why. Tell me if the delta H is positive or negative. Tell me if the delta S is positive or negative. And finally, verify through Gibbs if it's spontaneous or not. And go ahead and hit pause. Welcome back. So balance the reaction. What are some hints that we have here? We see that the type of reaction is combustion. So that's actually giving us a lot of information because it really doesn't seem like there's enough information here. But when we have a combustion problem, what do we always know? The products are carbon dioxide and water, and it needs oxygen as a reactant for it to happen. So that would be our setup here. If you did not get that as your setup, then hit pause and fix your work, and then hit unpause and try again. Okay, so again, it's a combustion. So what does that tell us? That tells us that we have to balance in CHO order. Balance the carbons, then balance the hydrogens, and then balance the oxygens. So I see I have 8 carbons on the left, so I need 8 carbons on the right. I see I have 18 hydrogens on the left, so I need 18 hydrogens on the right. 9 times 2 is 18. And now I have to do my oxygens, and the reason why we do this fast is because there's multiple parts. 8 times 2 is 16 oxygens and carbon dioxide. 9 times 1 is 9 oxygens in water, so I have 25 total oxygens. But I can't put 25 here because I have a 2. Something times 2 is 25. 12 and a half times 2 is 25. I fill in the last one, and then I notice, wait, what's the rule? No fractions for coefficients. So I know that if I have a 1/2 and I multiply things by 2, that's how I can simplify it to a whole number. So I'm going to multiply all the coefficients by 2. So now I have 2 moles of octane, excuse me, plus 25 moles of oxygen gas, plus 16 moles of carbon dioxide, and 18 moles of water. Let me put in some of those state symbols. Remember, state symbols are state of matter symbols. Octane, liquid. Okay. Oxygen, Brinkelhoff, gas. Carbon dioxide, gas. Water, in this case, we'll call water a liquid. Sometimes it's still in its gaseous state after that combustion, and then it settles down into a liquid, but we'll just do liquid right there. Why is dihydrocarbon liquid? Because he is so heavy that he's liquid. If you're at heptane or smaller, then it would also be a gas. So we balanced our reaction. Endo or exo, why? Oh, it's combustion. Combustion gives off heat. The heat exited. It's like if you had a candle and put your hand above the candle, not to get burnt, just close enough so that you can feel the heat coming off of it. That's not endo. The heat is coming off or exiting the reaction. So it's endo. That heat is exiting. Okay. Delta H. What does delta H mean? Delta H, that's your enthalpy, or sometimes it's called HRXN, your heat of reaction. So it's all dealing with the heats. Okay. You could see it listed multiple ways. Okay. Delta H, is it positive or negative? Okay, so I got to go back to endo or exo. Exo is negative, endo is positive. It needed that energy to pull it in. That's in chemistry only. Okay. So in this case, we're exo. So delta H is equal to a negative. How else could you see it written? Delta H is less than 0 because numbers less than 0 are negative. Heat of reaction, less than 0. Negative. enthalpy. Any of those ways you could see on the quiz to refer to it. So just remember, those are all meaning the same thing. Okay. Delta S, what's S? S is for entropy or disorder. It has that S there to remind you it's disorder that we're measuring, not order. So what are the things that we look through when we're calculating entropy? The change in moles. Okay, so how many reactant moles do I have? 2 plus 25, 27 reactant moles. How many product moles? 16 plus 18, 30, 29? Nope, that's not right. Let me use a calculator. I think it's 34. I think I was way off. 34, yes, I was way off. Thankfully, I would have gone the right direction because it's still increasing moles. So if you think about laundry on the floor at the start of the week, not much laundry, pretty organized. By the end of the week, you've tried on how many outfits, and you have more laundry just thrown on the floor. You're just tired because it's the end of the week. More laundry, more disorder. Delta S is positive. And remember, you could also write it delta S greater than 0, or entropy is positive. Okay, so lots of different ways to look at that. So where I have a delta H that's negative and a delta S that's positive, that's okay. You can have 2 positives, 2 negatives, or 1 of each. Now I'm still going to go through and double check the rest of the things for entropy. The first hint is when you look at change in moles. The second one, you look at the state of matter, and that's why those state of matter symbols or state symbols were important. We are going from a liquid and a gas to a gas and a gas. All right, so those gases are just going to cancel off there because there's a gas on the left and gas on the right. So I'm left with liquid to gas. Gas, disorganized, all random, all over the place. Liquid, it's not super organized, but it is able to have a constant volume. And that constant volume means that it is more organized than a gas. So we got more disorder. So that is also delta S is greater than 0. Sometimes they don't agree. So make sure you do check both of them so you can say not enough information or yes, it's positive. Okay, and we're not going to do the other checks because these are the 2 main ones. If they agree on the 2 main ones, then you don't have to do the other ones. Okay. And so what do we know? Delta H is negative, delta S is positive. Is that going to help us for our next one? Sure is. Delta H is negative, delta S is positive. So I find it on the graph here. Delta H is negative. What options do I have? Less than 0, negative. Delta S is positive, greater than 0. What options do I have? All right, what is the one? What's the row we're going to follow? The one we're matching the enthalpy and the entropy. So when you have to explain in the essay, the enthalpy and the entropy are showing that Gibbs is less than 0. Gibbs is negative. Okay, and Gibbs is the change in Gibbs. It's negative, and when that happens, it is always spontaneous. So use the chart because that's going to help you with those positive and negatives. Whatever thing you say, when you answer the essay, depending on which question you have, use these words here. Okay. Yes, no, those are the easiest ones. The other one, you can add both things. It depends on actual values, spontaneous at low temperatures. Depends on actual value, spontaneous at high temperatures. So pretty quick learning check today. Hopefully that's going to help you on that quiz. If not, remember you can always watch it again or set up a one-on-one. And have a great day. Remember to wait all the way to the end to hit submit.